A company claims that they will have you improve on a test score by at least 10 points. And so we took a pre-test and a post-test of 7 random people in this large group of people and tested their improved score. And so in this improved score, the first person improved by 5 points, 20 points, 20 points, 30 points, 15 points, 30 points, and 15 points. And we said that we wanted the population to be basically people in the program, and mu difference, or mu d, so I can't, equals the post score average test improvement. The new minus the old. And so here we have a null hypothesis where we said we were going to improve by at least 10 points. So the mu equals 10, and the alternate is mu is bigger than 10. And this is not one sample, but a paired t-test. And because they didn't specify, we're going to just use alpha equals 0.05. Okay, this was an SRS because we stated that. At least I think I stated that out loud. Independence. Well, how many people did we test? 1, 2, 3, 4, 5, 6, 7. So 7 times 10 equals 70, which is less than the total number of participants. And for normality, we need to try to check our box plot of these 7 numbers. When I made the box plot of those numbers, it will look like this. And since there's not only 7 numbers, it looks like it's a little bit skewed to the left. So we're going to say that this probably needs to be proceed with caution, because even though we don't have any outliers, we only have 7 data points. Alright, so I'm going to go to the next page to do the math, and we got an x bar equaling 9.28 from our data, and the standard error was 8.86. So when I grab this, here is mu of x bar equals 10. Sigma of x bar is equal to 8.86 divided by the square root of 7. And 19.28 is somewhere out here. And remember, our degrees of freedom is equal to 7 minus 1, which is 6. So t is equal to 19.28 minus 10 divided by 8.86 over the square root of 7. And that gives me 2.77 standard deviations. Now the probability that t is greater than 2.77 is equal to is 0.016. Remember, we're doing t CDF from 2.77 to a really big number with a degrees of freedom of 6. and this is less than 0.05. I reject the null hypothesis. I have reason to suggest people in the program go increase score, mean increase score is more than 10 points. And of course I should say that not reason but evidence. And there's my paired t-test. So just like the regular t-test, except for we're measuring the same people twice.